We know the theory of the k-means one. Now it's time for us to understand the code. This is the one that I already written, and I think it can save the times that you watch the video. And I post the link to this collab into the description of this YouTube video, so you can link visit this collab. This is how can we use the sklearn. In the sklearn, we have to import k-means one from sklearn.cluster, and because we have to work with the vector of the data, so I will use NumPy. So we start with an example X with 6 data. That is 1 1, 1 2, 2 1, 4 3, 4 4, and 5 3. So we have an X like this. So I will show you what is the values of X here. So our X will be this set of vectors. We have six vectors. That is 1 1 1 2, 2 1, 4 3, 4 4, and 5 3. This is X. So after we have X, we can use this one. K means using number of clusters. That is, we will cluster it into 2 clusters dot fit, and you can send X as the parameters, and then you can print the centroid of X, centroid of all clusters. In this case, we have 2 clusters. That is, the first one is in 1.333, and another one, X, the Y values is 1.333, and this is 4.333 and 3.333. And in this cell, I just plot all data here into this space. So you can see that we have the first cluster here, and this is another cluster. Okay, so I hope that you can see that it's quite simple, right? So you can add more. For example, you can add something like 4.2, 5.6, 2.3, 2.3, and 3.6, for example. Now we have 8, right? And then you have 2 clusters. It's still same. It's still same. But if you want to know the cluster, which cluster are like each example belong to, you can use km.label. This one. It will show an array of the label. So the first three data are in the first cluster. So the first 3 are this one. This is the first 3, and this is the last 4 or 5. So it will be in cluster number 1. So we have 2 clusters here. So we have this cluster that contains 5 examples, and this cluster contains 3. Okay, so now you can see that we have like the very easy one, right? Okay, now I will use the iris data. That is the one that we familiar, right? I used pandas to read the data from this URL. This URL is in UCI machine learning repository, and we read it in the DF, and I name it to be like 5 columns. Start with the sepal length, sepal width, petal length, and petal width, and the last one is the class. So I select just only the first 4 columns into our X data, and this is the k-means one that I start to use it just only 2 clusters, and this is the result. So you can see that because we have 4 attributes, right? Sepal length, sepal width, petal length, and petal width. So all of them are this. So this is the centroid of the first cluster, and this is the centroid of the second cluster. Okay, so this is the values of the sepal length. This is the values of the sepal width. The average values of sepal width in the first cluster. This is the average of petal length in the first cluster, and this is average petal width of the first cluster. So you can see that we have two clusters, and each cluster has four average attributes values. This is what we use the k-means one. We use the inner shear of the k-means as the quality of the clustering for k that start from 2 to 11 in this class. That is, we will work with 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we start with k to be 2 to 10, and then we use k-means and use number cluster to be k dot fit x, and then try to check the km dot inner shear, and then add it to the list of quality, and just plot the number of plot k with the quality. So this is what you can see. Okay, so you can see that we have the point. So in k is 2, the quality is these values. When k is 2, when k is 3, when k is 4, k is 5, k is 6. So you can see that along this line, it is like, oh, sorry. With this line, you can see that k is quite decreased dramatically, right? And this one is slightly. So it should be like the value to be the values of k that we should select is 3, 4, or 5 around here. But guys, so we can try with 3. So I start with number cluster to be 3, and then show the cluster center, and then I plot each centroid. You can see that when we have 3, our k is 3, right? And we have 4 attributes: sepal length, sepal width, petal length, and petal width. So you can see that for the blue line, this is the centroid of the first cluster. That is, all of them like very low comparing to each other. But for the sepal width, that is the second attribute, this is a little bit higher than the others. So, and this is the third one, and this is the fourth attributes. So, what we can see from here is if you want to see this centroid, you must choose just only some, like two of them. For example, if I choose sepal length and sepal width, I will use sepal length, that is the first attribute, and sepal width, that is the second attribute, and I show it here. So you can see that for the sepal length and sepal width, this one, sepal length and sepal width, the average of the first attribute, the sepal length, here we have sepal length as the first one, sepal width as the second one, petal length and petal width. So look at this. So the average of sepal length, that is lower. The average is lower. That is, average is around this point, right? That is lower than this group. Okay. And this one is the color of the class, not the color of the label. I will show you another one that is like the color should be the class. I will add the centroid add label to the data. Okay. This one, I add the label from k-means into the data frame dot label, and you can see here we have the data frame like this. So we have the label here, and instead of using the color to be df class, we use the label. Okay, and I will use the first two attribute, that is the first two attribute 0 to 1 and 0 to 1. Let's take a look. Yes. Tree clustered. Okay. So this one is the first two attributes of the centroid. Okay. A moment. Plot this one. X and Y. It must be 2. Sorry. Yes. So you can see that we have 3 clusters, and this is the first one, the second one, and this is the last one. Okay. You can see that because we use 4 attributes to cluster, so you can see some of them like this one or this one. It is like in this sepal length and sepal width dimension, it is like are here, right? It is close to this cluster, but maybe it's close because it's close to this cluster because the other two attributes. Okay, so you can see that this one is when we plot with these two attributes, we will have the centroid like this. Okay, so when we plot the data with the cluster, it will be like this. But when we plot the data, but with it must be petal length and petal width, it will be these values. So you can see that for the petal length and petal width, all 3 clusters are here. This is the first one, second one, and third one. Okay, it depends on the plane that you plot. Okay. Okay, so you can see the result of the 3 k is 3. Now I will change it. I will change k to be, look at this. You can see that for the 3 one, you have one cluster that is a little bit lower than the other twos, and for the other twos, this one and this one, it is like close to each other, but one is lower and another one is higher. That is these values. This one is the lowest one, the blue one, and this is one thing that is a little bit lower, and this is one is a little bit higher. Okay, so this is lower and higher one. So you can see that, okay, it's good that we can classify them to be like this. But guys, you can see from our elbow that we have k is 3 here and k is 4 here, right? So if you try to plot k is 4, what happened in this case? You have 3 lines in this group, 1, 2, and 3, right? And the other one is still same, but you can see that for the other groups, I'll show you the result. I'll keep it in label first and then plot it here. So it's like this group is still same, right? And this group has 3 centroid. And what next? So you can see that in petal length and petal width space, we have one group here that is separately good separated one. This is another one, and this is another one, and this is another cluster. So you can see that it divided into low, medium, and high. It's different from the previous one that when k is 2, there are just only 2 lines here, right? But it depends on your interpretation, that if you want them to be just only 2 groups, that is low and high, that's so fine, that you can use 4. Sorry, you can use 3, because in 3, k is 3. This is 1 line and there are 2 lines here. That is lower and higher. But when you increase k is 4, so it like high, medium, and low. Okay, so if we increase to be 5, what happened? So you can see that this line has no meaning anymore, right? Because there are just they divide this part into 4 groups. That is like, if you don't want to be like this, if you want just only lower and higher, or if you want to be low, medium, and high, you can choose the k that's suitable, that fit to your requirement, that fit to your interpretation. Okay, so that's all for the k-means one. I hope that you enjoy our k-means